Hello students, welcome back to the channel. So students, in this video we are going to study a very important chapter from your class 11th physics, which is Newton's laws of motion. The concepts that we are going to discuss in this video are very important for your final exams. 2-3 questions are surely going to come from these concepts. So before proceeding further, I would really like you to subscribe to this channel because we are going to bring so many videos which are very important for your class 11th and class 12th physics preparation. So let's start. This chapter is based on Newton's laws of motion. 3 laws were given by Newton. We will discuss all those laws, mathematics involved in them, and many important numericals based on this. So let's start. Let's discuss first law first. Obviously we are going to discuss the first law first. First law says that a body at rest remains at rest, or a body in uniform motion along a straight line continues to do so unless or until an external force is applied on the body. This is the same law that you might have studied in class 9th also. This law seems to be very easy, but students get confused when a situation comes where they have to apply this law. They get confused. So I don't want you to be confused. So let's take an example. This law says that if you want to change the state of a body, you have to apply a force. What is the meaning of this thing? What is the meaning of state? Here the meaning of state means if a body is moving with a uniform velocity and you want to change the velocity of the body, then you have to apply the force, or you want to change the direction of the body, you have to apply the force. That means force does two things on the body. It changes the direction of the motion of the body and it changes the velocity of the body. And if you do not want to change any of these, then there is no need of a force to be applied on a body. In the absence of an external force, the body continues to move along a straight line with the same velocity. Right? This is what the law is saying. Now let's take an example. If I ask you that a block is moving on this surface, right? This block is moving on this surface with a constant velocity. This block is moving on the surface with a constant velocity. This means that the net force acting on this block is 0, because if there is force, if there is net external force acting on the block, then it cannot move with a constant velocity. If it is given that this block is moving with a constant velocity, then it is necessary that the total forces acting on this block are unbalanced. For example, if we have applied a force of suppose 10 Newton, we are applying an external force of 10 Newton to push this block, and the friction against the block which is applied by the surface is suppose 6 Newton. Now an unbalanced force of 4 Newton, 10 minus 6, right? An unbalanced force, if force applied is 10 Newton on this side and 6 Newton on this side, that there is an external unbalanced net force of 4 Newton along this direction. So if there is a non-zero external force acting on the body, then the body cannot move with constant velocity. In this situation, this block cannot move with constant velocity. It will accelerate in the direction of net force. But if the friction is also, if the friction is also 10 Newton, if the friction is also 10 Newton and we are also applying the force of 10 Newton, then the net force is 0, and that force will make this block move with constant velocity. That is what the first law is saying. If you roll a ball along the ground, you would have seen that the ball stops after traveling certain distance. It stops due to the external force of friction, air friction and ground friction acting on the ball. But if we keep pushing the ball like this, we can make the ball move with constant velocity, because in that case the external force applied by us will be equal and opposite to the external force of friction acting on the ball. Both forces will cancel each other and the net force becomes 0, which will make the ball move with a constant velocity. right? If you go into the space where there is no gravity, where there is no friction, and if you throw a ball like this and the ball leaves your hand with a velocity of 10 meter per second, then it keep on going with 10 meter per second without any external force, because there is no gravity, there is no friction, then there will not be any factor to change the motion or state of the ball, right? This is what the first law is saying. So so let's summarize this discussion. So force is required to change the velocity of the body, external unbalanced force, not the force, because in this case also there are two forces acting on the body. Still this body is moving with a constant velocity because these two forces cancel each other. So there is no net unbalanced force acting on the body. So in the absence of a net unbalanced force, the body will move with a constant velocity along a same straight line. This is what the first law is saying. So force does only two things on the object. First, it changes the direction of motion. Second, it changes the velocity of the body. And if you do not want to change any of these, then net external force, net external unbalanced force is not required, right? Okay. Next thing is inertia. These topics in the beginning are theoretical topics, and from second law we are going to study some very interesting mathematics, and there are some many interesting numericals. So let's discuss this first and then we'll move to that. We won't take much time in this because these are the concepts that you have already studied in class 9th also. So what is inertia? Now we have thought that why a body cannot change its state by its own, then there must be some property in the body due to which the body is behaving like this, and that property is inertia, right? It is the property of the body which do not let the body to change its state. It resists any change in the state, and it depends only on the mass of the body, because it is difficult to change the state of a heavy body and it is easier to change the state of a lighter body. So if the body is heavy, much force is required to change its state. So we'll say that inertia of the body is more, like inertia. So have you understood what is inertia? Inertia means the inability of a body to change its state. The body cannot change its state without the help of an external force due to a property which is called inertia, right? And this inertia is of three types. First is inertia of rest. It is the inability of a body to change its state of rest without an external force. For example, this is a very famous example. When we are sitting in a bus and bus starts suddenly, we feel a backward jerk. This happens because when bus starts, our feet which are in contact with the floor of the bus starts moving, but as our body was at rest before, so it continues to be at rest, and to be at its original position, we feel a backward jerk. Students, when we are sitting in a bus and the bus is at rest, but suddenly the bus starts moving, what happens? We feel a backward jerk. Why this happens? Because our feet which are in contact with the floor of the bus, they start moving with the bus, but the upper portion of the body which is at rest and which wants to remain at rest due to inertia, so it tries to regain its original position. Before starting, this part of the body was somewhere here. So if the bus starts, then this part wants to remain in that position only. So feet travels with the bus in the forward direction and we feel a backward jerk of the upper body, right? What is inertia of motion? Inertia of motion is the inability of a body to change its state of motion, right? When we are sitting in a bus and the bus is moving and the bus suddenly stops, we feel a forward jerk. This is because the feet, same reason, the feet which were in contact with the floor of the bus, they stop with the bus, but the upper part tries to remain in motion due to inertia. So that's why we feel a forward jerk, right? And third one is the inertia of direction. It is very common to note that when we are sitting in a bus, we always sit in a bus. When we are sitting in a bus, when the bus takes a sharp right turn, we feel that we are falling towards the left side, and if the bus takes a left turn, we feel that we are falling towards the right side. This is happens due to the inertia of direction. Our body wants to remain in the same direction, it does not want to turn with the bus. So we feel that we are falling in the opposite direction, but actually what's happening is this bus suddenly moves towards right, and our body wants to remain in the direction, in the previous direction of the bus. So if the bus is moving towards this side, then what we will feel? We will feel that we are falling in the direction opposite to the turn, to the direction of the turn of the bus, right? So this is inertia of direction. Okay. Momentum is a very important physical quantity for this chapter, beta. Momentum is the product of mass and velocity of the body, and it is denoted by P. It is the product of mass and velocity, and since mass is a scalar quantity and velocity is a vector quantity, and the product of scalar and vector is a vector, so momentum is also a vector quantity whose direction is same as the direction of velocity of the body, because it is vector due to velocity. So this velocity vector is making this momentum as vector, so direction of this momentum is also same as the direction of velocity, right? So it is the product of mass and velocity. What will be the SI unit? SI unit of momentum. What is the SI unit of mass? It is kg. And what is the SI unit of velocity? It is meter per second. So this will be kg meter per second, which is the SI unit of moment, right? Okay. Why we have introduced the concept of momentum? Momentum in other terms is also defined as the quantity of motion contained in the body. Mathematically, it is the product of mass and velocity, but the actual definition of momentum is the quantity of motion contained in the body. From our experience, we know that if a heavy body is moving, then it contains more motion, and if a lighter body is moving with more velocity, it contains more motion. For example, if a bicycle and truck are coming towards us with the same speed, it is more difficult to stop the truck. Listen, the speed of bicycle and truck is same, but even then it is more difficult to stop a truck. Then what is the difference between bicycle and truck? It is just the mass. Difference between bicycle and truck is the mass. So if the velocity is same, even then truck has more motion. So what is the difference between bicycle and truck? It is just the mass. That means motion depends on mass also. And in second case for the same reason, much more force is needed to stop a bullet coming with much large speed as compared to bicycle, although its mass is negligible as compared to the bicycle. If you want to stop a bullet, don't even try to do that. If you want to stop a bullet, then you need more force, and you want to stop a bicycle, you need less force. Now what is the difference? The difference is in velocity. So that means motion depends on mass as well as velocity. Motion depends on both the quantities, and it is directly proportional to both of these. If the mass is more, then motion is more. If the velocity is more, then the motion is more. Then the product of mass and velocity is called momentum. It is very important to introduce the concept of force. Without momentum, we cannot introduce the concept of force, because force, what does the force do on an object? We have just discussed that the force changes the velocity of the body and the direction of the body. Velocity means the magnitude and direction both. So if we say that the force changes the velocity of the body, it includes both magnitude and direction. But basically, force changes the momentum of the body, and since mass is always constant, mass of the body is always constant, so instead of saying momentum, we say that force is required to change the state of the body, and by state we mean velocity. But basically, force is required to change the momentum of the body. Concept of force all depends on the concept of momentum, and which is second law. Now from second law, we are going to discuss some very good mathematics and many important numerical problems. Up to this topic, what we have studied is just theory. Now let's come to derivations and mathematics and all those things for which the physics is known. So it states that force acting on a body, this is the second law and it is the most important law. Second law is called the real law of motion because both first and third laws are contained in the second law, but we will come to that. Second law of motion, it states that force acting on a body is directly proportional to the rate of change of linear momentum. It says that the force acting on a body, suppose a body, there is a body which is moving, a body of mass m which is moving with a velocity u, and a force is applied on this body, and due to this force the velocity of the body is changed to v after some time t. Then this law says that this force acting on the body is equal to the rate of change of linear momentum. Rate of change of linear momentum means the momentum that we have discussed in the previous section. This momentum is also called the linear momentum, because there is another kind of momentum of the body which is called angular momentum, and that we are going to discuss in later chapters. So we can call it momentum or linear momentum, so one and the same thing. It states that force acting on a body is directly proportional to the rate of change of linear momentum. What is the meaning of the statement? It means that force equal to change in momentum divided by the time taken to change the momentum. Right? For example, we can write it as P final minus P initial divided by time taken by the body to change its momentum from final to initial to final. For example, this body was moving with velocity u, so its momentum at this position was m into u, mass into velocity, and at this position the momentum is m into v. Then we can say that Pf is m into v minus Pi is m into u divided by t. Right? So this is what this equation, this law says. Now if we take m as common, then v minus u upon t is left, and we all know that v minus u upon t, v minus u upon t means what? This is acceleration, na, change in velocity by time. So F equal to ma. This is another famous statement of the second law, but the actual meaning of the second law is this. This is just a byproduct of this meaning, right? We can easily derive this equation from this thing, but this is not the second law, this one is the second law. So you have to understand this statement. So more the force on the body, more momentum change will occur in the body in short span of time. For example, a football is kept here, and a man comes and kicks this football in a lazy attempt like this. So what will happen if we note the velocity of the football after 1 second? Now here the velocity is 0, and due to this lazy kick in 1 second, suppose in 1 second the velocity becomes 2 meter per second, and the mass of the football was 1 kg. Suppose mass of the football was 1 kg, right? Then what is the force? Force comes out to be very small. Force comes out to be very small. Change in momentum. Final momentum is 2 into 1, m into v. 1 into 2, 2 into 1, 1 and the same thing. So 2, initial momentum is 0 divided by time taken 1. Time taken 1 second. So what was this force? This force was of just 2 Newton. SI unit of force is Newton. We are going to discuss that shortly. Okay, 2 Newton. Now let's take one more example. Now this boy starts running from this. Okay, this force is 2 Newton, just keep that in mind. Now this boy starts running from here, and then he comes and kicks this football with full power, and after 1 second, you know then in previous case, after 1 second, the velocity of this football was 2 meter per second. Obviously, in this case, in just 1 second, this football is going to gain a much higher value of velocity. Now suppose after 1 second, उड़ती हुई गई, after 1 second इसकी जो velocity थी, after 1 second, suppose इसकी velocity was 10 meter per second and initial momentum was 0 and the mass of the football was 1 kg. Then what is the force? 10 into 1 minus 0 divided by 1. So in this case, it is 10 Newton force, right? So if the value of force is more, you can change the momentum of the body on which the force is applied. You can change more momentum of the body in the same time, right, by applying more force. This is what this law says, and this is one statement of this law and this is another statement, and this is very useful in numerical problems. But if the time is very small, say dt, and in that small time the change in momentum of the body is dp, then we can say then f is dp by dt, rate of change of linear moment. Okay, so you can get this type of question also if p is given as a function of t and you have to find the force, then you have to differentiate this p with respect to t to find the value of the force, right? So this is the second law, but there is more to it. First of all, let's discuss the units of force. SI unit of force is Newton, and which is equal to kg meter per second square, right? F equal to ma. So this force is going to come in SI units if the mass is in SI units and acceleration is in SI units. So mass, SI unit of mass is kg and SI unit of acceleration is meter per second square. This unit, one value of this unit is called 1 Newton. So 1 Newton is 1 kg meter per second square. If we have to define what is 1 Newton, then we will say that force is said to be 1 Newton when it can produce an acceleration of 1 meter per second square in a body of mass 1 kg. And the CGS unit of force is called dyne. CGS means when the mass is taken in grams, length in meter, time in second. So 1 dyne m into a is 1 gram centimeter per second square. So force is defined as 1 dyne when it produces an acceleration of 1 centimeter per second square in a body of mass 1 gram. Okay. There is another unit that we are going to use in this chapter, and that is kgf, not the movie. Kilogram force. It is called kilogram force and it is equal to 9.8 Newton. You know that the formula of weight of the body is m into g, where g is acceleration due to gravity. Then what is the weight of a body of mass 1 kg which is kept on the surface of the earth? That is 1 into 9.8, which is 9.8 Newton, and that value is called 1 kgf, not the movie. Okay, now let's discuss a numerical based on second law of motion. A bullet of mass 0.04 kg moving with a speed of 90 meter per second enters a heavy wooden block and is stopped after a distance of 60 meter. What is the average resistive force exerted by the block on the bullet? Now here we have a wooden block wood lag raha hai ye? Okay, let's say it is a wooden block and a bullet is fired on this wooden block and the mass of the bullet is 0.04 kg. And this bullet is coming with a speed of 90 meter per second. This bullet is coming with a speed of 90 meter per second. It enters this heavy wooden block and it is stopped after traveling a distance of 60 centimeter. Now it travels a distance of 60 centimeter. It travels a distance of 60 centimeter and it stops somewhere here after traveling a distance of 60 centimeter. Now we have to find the average resistive force exerted by the block on the bullet. Now what happens here? This block will exert a resistive force. Resistive force means a force which is trying to retard the motion of the bullet, and this block will apply a resistive force on the bullet, due to which this bullet stops after traveling a distance of 60 centimeter, and we have to find the value of that resistive force. So we know that force is mass into acceleration, and we know that the mass of the bullet is 0.04 kg. Now what is acceleration? 0.04, but now let's put this in the form of symbols first. M into A. What is A? A is V minus U by T, which is not suitable for this question because time is not given. So to find acceleration, we are going to use third equation of motion, which is V square minus U square equal to 2as, because distance is given now. So this is 0 minus initial velocity of the bullet is 90 meter per second. 90 ka square 2 into A into 60, but that 60 is in centimeter, so we will divide it by 100 to convert it into meter. So what is the square of 90? 80, 100 equal to 112 by 10a. So what is acceleration? Acceleration is minus 81,000 divided by 12. Both these are multiples of 3, sorry. So let's cancel it by 3. So 3 into 2, 6, 21, 7, 0, 0, 0, 4. Now, and 27,000 is a multiple of 4. So 20 into 6, 24, 30, into 7, it's 28, 20 into 5. Okay. So it is, acceleration is coming out, I'll write it here, right? Acceleration is coming out to be minus 6750 meter per second square, because it is retardation, so we are expecting it to come with a negative sign, and it is coming with a negative sign, right? So then what is the force? Force is, what is the mass? Mass is 0.04. So the force is 0.04. Since it is a retarding force or resistive force, it will also come out to be negative. So the answer is 5 into 4 is 20, 7 into 4 is 28, 33, 6 into 4 is 24 plus 3, 27, and we'll put one more 0 and negative sign and decimal here. So the answer is minus 270 Newton. Answer is minus 270 Newton, right? Next. A machine gun of mass 10 kg fires 20-gram bullets at the rate of 10 bullets per second with a speed of 500 meter per second. What is the force required to hold the gun in the position? Okay. What is the mass of the machine gun? Okay, what's happening here? There is a machine gun of mass 10 kg and it is firing bullets at the rate of 10 bullets per second, and the mass of each bullet is 20 grams. So what is happening is that, because initially the bullets were part of the gun, and now if the gun is firing those bullets, then the mass of the gun is decreasing with time, and if the mass is decreasing, then momentum is changing, and the momentum is changing, a force will act on the gun. So we have to apply an equal and opposite force to keep that gun in position, right? And we have to find the value of that force. So what is force? Force is the rate of change of momentum. So here velocity is not changing, mass is changing. So if we take time as 1 second, then what is the change in mass? We can say that F is delta P by delta T, and delta P is delta M into V. And according to question, we have to see that what is changing, M is changing or V is changing. Here the M is changing, so we will take V outside. Now it becomes this. Now this formula will give us force. If we take delta T, as 1 second, because the data given is this in this question is for 1 second, right, per second. So if we take delta T as 1 second, then the force comes out to be velocity of each bullet is 500 meter per second. 500 into delta M. What is the change in mass? 20-gram bullets are fired, and total 10 bullets are fired in 1 second. So what is the total mass which is leaving the gun in 1 second? That is 200. 20 into 10, that is 200 gram. But we will change gram into kilogram, because we are going to find this answer in Newton. So everything should be in standard units, right? So answer is 50 into 2, that is 100 Newton. So we have to apply a force of 100 Newton to keep this gun in position. Now the mass of this gun was not required in the question, in the solution, but it was given in the question just to confuse you. हुए तो नहीं ना confuse? Impulse. Okay, the next thing is impulse. It is the product of force and time. What is impulse? Impulse is a vector quantity which is the product of force and time. There is a very important term in impulse which is called impulsive force. Impulsive force is a force which comes in contact for a very small time with the body. For example, when two bodies come in contact for a very small time, then the force applied by one body on the other, that is called impulsive force. For example, when a bat hits a ball, then what is the time of contact? Time of contact is very small. It is less than 1/10 of a second. So that force which is applied by bat on the ball in this very short duration, that is called impulsive force. Or when a hammer hits a nail, hammer applies force on nail for a very small fraction of time, and that is called, my friends, impulsive force. Okay, impulse is a vector quantity because it is force into time. Force is a vector quantity, time is a scalar quantity, and I have put this vector sign over the symbol of time. What is happening with me? So impulse is a vector quantity because it is the product of force and time, and force is a vector quantity and time is a scalar quantity, and again the product of scalar and vector is a vector quantity, so impulse has to be a vector quantity. Okay, according to second law, according to Newton's second law, force is what? Force is delta P, change in momentum by delta T, time, right? So what is delta P? Delta P is F into time. Don't think that this delta T is different from T. This also represents time and this also represents time. So from these two, this is first and this is second. From these two, we got that impulse is nothing but it is equal to the change in momentum, and that is the most important thing from this part, that impulse is nothing but it is equal to the change in momentum of the body, and this final relation is called impulse momentum theorem. This mathematical statement has a special name and it is called impulse momentum theorem. It is called impulse momentum theorem, right? Okay, what is the SI unit of impulse? SI unit of impulse is, it is force into time, so SI unit of impulse is Newton second, right? Newton second. And since it is equal to change in momentum, then there is one more SI unit of impulse which is same as the SI unit of momentum, which is kg meter per second. Clear? Okay. Okay, now let's take some examples based on the concept of impulse. A batsman hits a ball straight in the direction of the bowler without changing its initial speed of 12 meter per second. A ball is coming towards the batsman. A ball is coming towards the batsman, and this batsman hits the ball with this bat. Not this is not an ice cream, it is a bat. And this batsman hits this ball back along the same straight line with a speed which is equal to the initial speed. So this ball came with a speed of 12 meter per second and it goes back with the speed of 12 meter per second. If the mass of the ball is 0.15 kg, if the mass of the ball is 0.15 kg, determine the impulse imparted to the ball. Now we have to find the impulse, but since impulse is a vector quantity, momentum is a vector quantity, force is a vector quantity, and if the body is changing directions in the question, then we have to use the sign conventions, right? Initially this ball was traveling towards right, and after the batsman hits the ball is traveling towards left. So the direction of change, the change of direction occurs in the question. So let's take this direction as the positive direction, and now let's take this direction as the negative. Obviously if this direction is positive, then this is automatically taken as negative. So what is the impulse? Impulse is change in momentum. What is initial momentum? Pi. Initial momentum is mass into velocity, right? Initial momentum is this. So what is 15 into 12? It is 180. So this will give us 1.8. Initial momentum is 1.8 kg meter per second. Initial momentum is 1.8 kg meter per second. What is final momentum? Final momentum is 0.15, since the direction of velocity is changed. So instead of 12, we will put minus 12, right? And this comes out to be minus 1.8 kg meter per second. So what is impulse? What is impulse? Impulse is nothing but change in momentum, and change in momentum means final momentum minus initial momentum. Final momentum is minus 1.8 and initial momentum is 1.8. So if we'll subtract 1.8 from 1.8, we will get minus 3.6 kg meter per second, right? So this is impulse. Minus is coming because we have taken this direction as negative. We can take any direction as positive and the opposite direction will be negative. So the magnitude of change in impulse is 3.6. So the answer is 3.6 kg meter per second. But according to the questions perspective, if you leave this as minus 3.6 kg meter per second, then it is also okay. Nobody is going to deduct any marks. Next, a ball moving with momentum of 5 kg meter per second strikes against a wall at an angle of 45 degree and is reflected at the same angle. Calculate the change in momentum. Okay, this is one of the most important numericals from this chapter. So it is given that there is a wall and a ball is hitting this wall at an angle of 45 degree. Suppose this is the ball. It comes and hits the ball. This ball comes and hits the wall at an angle of 45 degree and is reflected at the same angle. Obviously it will not go in this direction, ball will go in this direction. So the reflected angle which is given as again 45 degree is this angle, right? This angle. Now we have to find the change in momentum, and since change in momentum is impulse, in other words we have to find the impulse. Okay, since impulse is a vector quantity, so you cannot directly apply the formula impulse final momentum minus initial momentum. You have to first take the components, because the direction of final momentum and direction of initial momentum is not same. So we have to take the components first. Now suppose this is the axis and the momentum of this ball is 5 kg. The momentum of this ball is 5 kg meter per second, which is pi, which is the initial momentum, and the final momentum is also same. So let's take it as p, because initial and final momenta both are same, so we'll take them as p. The direction of this p is this, right? So let's resolve this into two rectangular components. If this angle is 45, then this is also 45, this is also 45, this is also 45, this is 90, this is also 45, all these angles are 45. So if this is p, then this is p cos 45 and this is p sin 45. Okay, and final momentum of this ball, final momentum is directed towards this direction, because momentum, the direction of momentum is the direction of velocity, and the ball is moving in this direction, then momentum is in this direction only. So it is 5 kg meter per second in this direction. So now let's take the components of this also. This is also p, same value, and this component is p cos 45, and this component is again, it is written here so I will not write it again, this component is again p sin 45. Okay, so the x components are in opposite direction. Before hitting the ball, the x component of this ball was in right direction, and after hitting the ball the x component was in left direction. But the y components, both the y components before and after hitting the ball, both the y components are in same direction. Now if you will subtract these two, you will get 0, because they are in same direction, so they have same magnitude, they have same sign. So if you will subtract this, you will get 0, and if you will subtract these, you are not going to get 0. Delta p is the difference of these two. Now let's take this direction as positive. Now let's take this direction as positive and this direction as negative. So this momentum is positive and this is negative, but this is the final momentum. So minus p cos 45 minus p cos 45 minus initial momentum, which is again p cos 45. So we just put the value of hello, yeah, it's coming. It is minus 2 p cos 45 is 1 by root 2. 2 by root 2 is nothing but root 2. So it is minus root 2 into p, and the value of p is 5. So it is, we will write it in standard form. It is 5 root 2 kg meter per second. That is change in momentum, and that is impulse also. You can call it anything. Next. Okay, students, there is a concept which says that if A is the product of B and C, if A is a physical quantity which is the product of two physical quantities B and C, then graphically the value of A will be the area under the graph between B and C. For example, velocity is the product of, displacement is the product of velocity and time. Displacement is the product of velocity and time. So to find the value of displacement from velocity time graph, what we do? We find the area under the velocity time graph. Similarly, work is the product of force and displacement, and to find work, we find the area under force displacement graph. And now here, since impulse is the product of force and time, so graphically if we want to, or we have to find the impulse, we will find the area of force time graph. A force acting on a body of mass 2 kg varies with time as shown. This is the force time graph. Find the impulse of force and final velocity of the ball. Now what is impulse? Impulse is the area under, मैं लिख देता हूं यहां, impulse is the area under force time graph. It is the area under force time graph. Okay, now we have to find the impulse in this case. Now what is the area? This figure seems to be a trapezium, and what is the area of the trapezium? Area of the trapezium is half into sum of parallel sides. It is half into sum of parallel sides into distance between them. This is the formula for the area of trapezium, na? So half into, what is the length of parallel sides? 5 and 2 to 3. This is 1, this is 5. So half into sum of parallel sides, which is 5 plus 1, which is 5 plus 1 into, what is the distance between these two parallel sides? It is 4 units into 4. So the answer is 6 into 2, that is 12 Newton second. So impulse is 12 Newton second. Okay. Now let's discuss the second part. What is the final velocity of the ball? Since impulse is change in momentum and that is 12. So it is initial momentum is 0 because there was no force acting initially on the body. Then the velocity of the body, let's suppose that the velocity of the body was 0, right? So this must be equal to the final momentum. Final momentum is 2 into the final velocity of the body. Because initial velocity is not given in this question, so let's take it as 0. Yeah, at t equal to 0, there was no force acting on the bodies, and so the value of v is 6 meter per second. So the final velocity is, assuming that the initial velocity is 0, or it is evident from this graph, so the final velocity is 6 meter per second. Next, so students, now we are going to study some very important points. You can get conceptual questions based on these. These points will be explained on the basis of the concept of momentum, force, second law and impulse that we have studied till now. So all the concepts are based on just fundamental thing only. Since force is change in momentum by time, so if you want to reduce the value of force, then you can bring about the same change in momentum in a larger point of time. Since force is change in momentum by time and time is coming in denominator, so by increasing the denominator we can reduce the value of force. So if we will take more time to bring a change in momentum, then the force will decrease accordingly, right? For example, glasswares are wrapped in paper or straw. Glasswares are wrapped in paper or straw, so in case it falls, the impact will take a longer time to reach the item. Therefore, the force will significantly reduce. For the same reason, the vehicles are provided with shockers. Shockers, what happens when a vehicle hits a pit? The impact of that pit takes longer time to reach the rider because it passes through the shocker. And since the time is more, the force of the jerk reduces to a significantly small amount. A cricket player lowers his hands while catching a cricket ball. When a ball is coming towards the cricketer, you must have seen that the cricketer lowers his hand. He is trying to increase the time. To change the momentum of the ball is coming with a particular momentum. So to reduce that momentum to 0, he is taking more time so that the force which the ball is applying on his hands is reduces and he doesn't get hurt. and for the same reason bogies of train are provided with buffer. So all these points can be explained on one simple fundamental concept that we have discussed. Now let's discuss about the conservation of linear momentum. Conservation of linear momentum says that if the net external force acting on a system is zero, then the total momentum of the system remains conserved. This is a simple thing to understand. What we have to do, we have to understand the meaning of the word system which is used in this definition. We have not used the word body. Why we have used this word system? Okay, we'll discuss. But we know that F external is delta P by delta T. Till now we were writing F as F only, but why we are emphasizing it as F external? Because student, there are many forces which are acting on the body from inside, but they do not contribute towards changing the momentum of the body as a whole. For example, in this body there are millions of electrons, protons, molecules. They all are applying forces on each other. There are electrostatic forces, magnetic forces, van der Waals forces, cohesive forces, adhesive forces, right? But all those forces are not changing the momentum of this body. So to change the momentum of this body, we have to apply an external force. So in this formula, F was always the external force, but we did not discuss that thing in that part because it is needed here. So F external is delta P by delta T, and if F external is 0, then delta P by delta T is 0, and if the derivative of something is 0, derivative means the rate of change, but the rate of change is 0, then that particular quantity is not changing at all. So if delta P by delta T is 0, we can say that the momentum of the system is constant. But what is the meaning of the system? Let's call the boy again which was hitting the football. Now this is a boy and this is a football. Now if we take football as another system and this boy as another system, so when this boy kicks the football, that kick, the force that kick applies on the football is taken as an external force because we have not considered this boy as the part of the system. So any force which boy applies on the football is an external force. So the momentum of this football will change because external force acting on the football is not zero. This is what this law is saying. If the external force is not zero, then momentum will change, and obviously the momentum of this football is changing because initially this football was kept on the ground, so the momentum was zero. So when this boy hit the football, its momentum is non-zero, so momentum is changed, and it has to change because the external force is not zero, right? Okay. Now if we consider this boy as the part of this system, now this boy and football both are the parts of the same system. Now if this boy hits the football, then that kick becomes the internal force. The force which that kick applies is the internal force, and this law says if the force is internal, then the momentum of the system as a whole will not change. Now the system is what? System is the boy and football. Now let's suppose this boy was coming towards the ball with a momentum of suppose 10 units. Let's say 10 units, which means the mass is very, that means the mass of the boy is very small. Let's say this boy was coming towards the football with a momentum of 100 units, right? And the momentum of the football was 0. So initially, before the boy kicks the football, the total momentum of the system means the boy and the football, the total momentum was again 100 because 100 plus 0 is 100. Now when this boy hits the football and the boy himself stops after hitting the football, then the football will attain a momentum of 100 because the kick of this boy is an internal force which is not going to change the momentum of the system. So if the initial momentum of the system was 100, then the final momentum will be 100 of the system. means the total momentum of the boy and the football. Since the boy stops after hitting the ball, so the momentum of the boy after kicking is 0. So the whole momentum of the boy gets transferred into the ball. So again the total momentum of the system is 0. Suppose is 100. Suppose this boy does not stop after kicking the ball and the boy has momentum of 40 units. That means the ball will gain a momentum of 60 units. So that again the sum is 100. So it's up to us. If we consider this boy as the part of this system, then again the law is valid because internal force becomes 0. And if we do not consider this boy as the part of this system, then also the law is valid because then this kick becomes the external force. So there are few important concepts based on the law of conservation of linear momentum. This was in class 9th also. Recoil of gun. When we fire a bullet from a gun and suppose this bullet leaves the gun with velocity v, we all know that there is a recoil in the gun, and suppose that recoil velocity is v. Why there is recoil in the gun? Initially, if we consider gun and bullet, both are the parts of the same system, and the gun was kept on the table and bullet was there in the gun at rest. So the whole momentum of the system was 0. Initially, the momentum of the system before the firing was 0. But after firing, suppose the mass of this bullet is small m and mass of the gun is capital M. After firing, this bullet moves in forward direction with a momentum of m into v. And since there is no external force acting on the system, so the total momentum of bullet gun system has to be 0 after firing also. So if this bullet is moving in forward direction with a momentum m into v, since momentum is a vector quantity, so this gun should have a momentum equal to this in the backward direction, so that both these momentum of the gun and momentum of the bullet, they cancel each other, and total momentum after the firing is also 0, right? So sum of the momenta of these two is again 0. So v, which is the recoil velocity of the gun, is mv by capital M, which is the mass of the gun. So recoil velocity is inversely proportional to the mass of the gun. So we make guns heavy so that they have less recoil velocity and we can hold those guns easily in our hand. Okay. So product of mass and velocity of both bullet and gun, the product is same, right? Since mass of the bullet is much smaller than the mass of the gun, so velocity of bullet in forward direction is much greater than the recoil velocity of the gun in the backward direction. Bomb explosion. Suppose this bomb explodes into 2 fragments. It can explode into 2 fragments, it can explode into 3 fragments. So you must have seen have you seen the explosion of a bomb? We are not talking about the bigger bomb, we are talking about a small cracker. That suppose, just imagine and you will get to know the meaning. Suppose this bomb explodes and divides into 2 fragments. So we all know that both those fragments, they do not move in same direction, they always move in opposite directions. It is due to the law of conservation of momentum. Before explosion, both the pieces were at rest, so the total momentum of the system is 0, and this bomb explodes due to internal forces. There is no external force, so the total momentum after the explosion should also be 0. It is possible only if one fragment travels in one direction and the other fragment travels in the opposite direction. Suppose the mass of this fragment is m1 and mass of this fragment is m2. If this travels in this direction with velocity v1 and it travels in this direction with velocity v2, then m1 v1 plus m2 v2 should be 0. Now they are moving along the same straight line, but even if there is a third fragment which is moving in some other direction, then the total vector sum of the 3 particles, the momenta, vector sum of momentum of the 3 particles will again be 0. We'll do a question like that, right? Okay. There can be some other situation also, like this bullet is coming towards this wooden plank, and mass of the plank, let's say the mass of the plank is capital M and the mass of the bullet is small m, and the velocity with which this bullet is coming towards the plank, that is v. Now when this bullet hits the plank, it gets embedded. This bullet gets embedded in the plank, and both of these will now move with the same velocity. Both of these will now move with the same velocity, right? Because now this bullet is nothing but a part of the plank. Now they are both moving with a common velocity v. So what is the equation that can be applied? So in all the situations, based on the concept of the conservation of linear momentum, there is something called impact. For example, impact in this case was the firing of gun, impact in this case was the explosion of bomb, and impact in this case was the bullet when it hits the plank. So the total momentum of the system before the impact is equal to the total momentum of the system after the impact, and this is how you can make the equation. So the total momentum of the system before the impact total momentum of the system before the impact was this, because the momentum of the bullet was m into v and momentum of the plank was 0. So total momentum was this, and after firing they both acquire same velocity because they are moving together. Now bullet is the part of the plank, so total mass becomes m plus m and that velocity v. And in these type of questions we are supposed to find this common velocity, so this comes out to be this, right? So this is the type of situations that you are going to get in numerical problems. For example, a bomb explodes into 3 fragments of equal masses. 2 fragments fly off at right angles to each other. Now this is the question I was talking about. This is a bomb, it explodes into 3 fragments. 1, 2 and suppose 3, right? This fragment is moving, it flies off in this direction, this fragment flies off in this direction at right angles to each other with velocities of 9 meter per second. So this velocity is 9 meter per second and 12 meter per second. Calculate the speed of the third fragment. So students, third fragment will move in such a way that the resultant momenta of these two particles comes out to be 0. For that the momentum of the third particle should be equal and opposite to the resultant of the momentum of these two particles, right? A bomb explodes into 3 fragments of equal masses, so the masses of these fragments are equal. Now let's say the mass of this is m, mass of this is also m, mass of this is also m. So what is the momentum of this particle? 9m. What is the momentum of this particle? 12m. Since they are at right angle to each other, so net momentum is the resultant of these two, which is square of this plus this. It is 81m square plus 144m square. So the momentum, the resultant of the momenta of these two particles is 15m, and in this direction, according to parallelogram law, the resultant is in this direction. So the momentum of the third particle should be exactly equal and opposite to the resultant of these two, so that the net comes out to be 0 here. And what is the resultant? It is 15 m. Then the momentum of this particle should also be 15 m. Momentum of third particle P3 should also be 15 m. And since mass of the third particle is also m, now if we cancel m by m, we get that the velocity of third particle should be 15 meter per second. Calculate the speed of the third fragment. Speed of the third fragment is 15 meter per second. Next, a man weighing 60 kg runs along the rails with a velocity of 18 km per hour and jumps into a car of mass 1 quintal standing on the rails. Calculate the velocity with which the car will start traveling along the rails. Okay. There is a man who is running in this direction. The mass of the man is 60 kg. The mass of the man is 60 kg and it is running in this direction with a speed of 18 km per hour. A car is standing on the rails, suppose here, and this man jumps on the car. Mass of the car is 1 quintal. 1 quintal means 1 quintal is what? 1 quintal is 100 kg. So mass of this car is 1 quintal. So if this man will jump on this car, then what is the velocity with which this car will start traveling along the rails? Now here we have to apply the concept of the conservation of linear momentum again. So the impact here is the jump of this man on the car, right? So the total momentum of the system is man plus car. So the total momentum of the system before the jump was just the momentum of this man because the car was at rest. So it is 60 into 18 km per hour, but let's convert kilometer per hour into meter per second by multiplying it by 5 by 18 plus 0. 0 is the momentum of this car. Now after jumping, this man is the part of the car, so they both are moving with the same velocity, right? And let's take that velocity as v. So what is the total mass of the system now? When the man is standing on the car, the total mass of the system is 100 plus 60, 100 plus 60, and the common velocity is suppose v. So the value of v is 60 into 5, that is 300 divided by 160. So the answer is 30 by 16, which is 15 by 8 meter per second. So the car will move with a small velocity of 15 by 8 meter per second. Next. Okay, various forces and free body diagrams. Students, before moving further, we have to understand the concept of the different forces that we are going to use in numerical problems after this topic, and how to make free body diagrams and apply the equations. So there are three major forces that we are going to use in different numericals, and the first force is weight. Now what we are going to discuss? We are going to discuss some numericals in which we have to apply some forces on the objects which are not given in the question. We have to think about those forces by ourselves, and we have to apply those forces on the objects, and we make free body diagrams, and on the basis of those free body diagrams we make equations using Newton's second law of motion, and after that we solve the question. So there is a series of steps. So let's start with the forces first. What are the different forces that we have to apply? First one is weight. In each and every question you will use a force acting on the body, which is weight. Weight is the force with which each and every body is getting attracted towards the center of the earth, and it always acts vertically downwards. If the body is in air, even then the weight is acting downwards, and the formula of weight is m into g, where m is the mass of the body and g is acceleration due to gravity. If the body is kept on an inclined plane is this surface which is inclined at some angle theta. If the body is kept on the inclined plane, then even then the weight will act vertically downward. If the body is in air, or it is kept on an inclined plane, or it is kept on a horizontal surface, nothing changes. Weight will always act in vertically downward direction, and this force acts from the center of the body, and this force will be taken in each and every questions we will discuss. Okay, normal reaction. What is the normal reaction? It is taken only when the body is in contact with the surface. Whenever the body makes a contact with the surface applies an equal and opposite force on the body just to support the body, right? If this stylus is kept on this hand, then this stylus is applying a weight on the hand. Then why this stylus is not going into the hand? So there must be some force which is cancelling the weight of this stylus, and that force is normal reaction applied by my hand on this stylus. So it always acts perpendicular to the surface, and it acts only when the body is in contact with the surface. If the body is falling or it is in air and it is not in contact with any surface, then there is no use of normal reaction in those questions. But if the body is kept in contact with the surface, for example, on horizontal surface, weight of the body is acting downwards, so the normal reaction will act upwards, right? On an inclined surface, weight acts in this direction, that we have already discussed. But normal reaction always acts perpendicular to the surface towards the body. Normal reaction is taken by N, by the symbol N, or by capital R. We can use both the symbols, capital N or capital R. I am using capital N. You can use capital R also. It always acts perpendicular to the surface towards the body. Perpendicular तो ये भी होता है, नहीं, towards the body. Surface will apply the force on the body, right? And it acts at each and every point of contact. For example, let's consider this surface and a spherical body is kept here, suppose like this. A spherical body is kept on this surface. So this body is touching this surface at 2 points, this one and this one. So the normal reaction will be at this point also in this direction, and at this point also in this direction, right? So there are two normal reactions. So this is how we are going to apply normal reaction. The third force is tension. Tension acts along the rope and away from the body. Tension comes in those questions only in which there are ropes involved. For example, now here is a body, and there is another body. Now suppose these two bodies are connected by a rope. And here one more rope is connected. Now if we pull this rope with force F, whole system will accelerate in this direction, right? So there is a force developing in this rope. You can pull this body is being pulled by this force. But why this body is being pulled? There is no direct force applied on the body. This body is pulled due to the connection of this rope with the body. If we cut the rope, then this second body will not move. That means this rope is responsible for applying some kind of force on the body, and this rope applies the force only when the rope is taut, खिंची हुई हो जब rope, है ना, ढीली ढाली rope हो, then there will be no force. So in taut ropes, in stretched ropes, there is a force which develops, and that is called tension, and it always acts away from the point of contact. For example, if we want to find the direction of tension at this point, then it is away from the body, and at this point it will be in this direction, but since the rope is same, both the tensions will be same, because we consider that the ropes are massless and frictionless, and if the ropes are massless, then the tension will be same at every point. And what happens if there is some mass of the rope? We are not going to get those questions at school level. Those questions are for JEE only, so we are not going to discuss that concept. We will consider that the rope is massless, and if the rope is massless, the tension at every point is same, right? For same rope, since this rope is different from this rope, so the tension in this rope will be different. Here the tension is suppose T dash, and this T dash will be equal to F, because this is the only force which is responsible for producing the tension in this rope, right? So this T dash is equal to F. So now let's discuss about the free body diagrams and forming the equations. For this we will take some important examples that are very important for school exams. From this ceiling, a pulley is hung and a rope is connected over the pulley, and two bodies are connected with the two ends of the rope. Now let's say the mass of this first body is m1 and the mass of this second body is m2. Now if this system is, someone is suppose holding these two bodies, and if the system is released now, what is the acceleration of the bodies and the tension which is developed in the rope? What is the acceleration of these two bodies and the tension which is developed in the rope? We have to find these two things. Now what we will do, we will make something which is called free body diagram. Now let's take this body as 1 and take this body as 2. Now we will form FBD. FBD means free body diagram. We will form the free body diagram of 1. We will form the free body diagram of 1. Okay, free body diagram means you will just take the body as a point object, and by using arrows we will make the various forces which are acting on the body. For example, on M1, various forces means only out of the three forces that we have discussed: weight, normal reaction and tension. And since there is no surface of contact, so normal reaction does not have any work in this question, and the ropes are connected, so there must be tension. So m1g is the weight of the first body, and that always acts in vertically downward direction. So m1g will act in this direction. Okay, and what is the other force? Other force will be tension. Tension acts along the rope away from the body. So the other force in this case is tension in the upward direction. Let us suppose this system is moving such that it is accelerating in upward direction. So this body will accelerate in downward direction. Since the rope is taut, there is no slack in the rope. So both these bodies will move same displacement in a given point of time. So if their displacement is same, then their velocity is same, hence their accelerations are same, right? So acceleration of this body, if the distance moved by this body is x in upward direction in time t, then this body will also move by a distance x in downward direction in time t. So displacement is same, the velocity is same, and acceleration is same, right? So if the acceleration of this is a, then acceleration of this one is also a. Okay, so the acceleration is in upward direction. Now the everything is in y direction. There is nothing which is in x direction. So in next question we are going to discuss the components and all those things, but that is not required in this one. So we know that body always accelerates in the direction of net force. So if the body is accelerating in upward direction, then the net force is in upward direction. So T is more than m1g. So the equation is T minus m1g equal to m1a. T minus m1g equal to m1a. So this is the equation of the first body. Now let's make FBD of the second one. Now let's make FBD of the second one. M2G is acting in downward direction, T tension is acting in upward direction, and this body is accelerating in downward direction, then M2G must be greater than T, because body always accelerates towards the more force. So M2G minus T equal to M2A. So these are the two equations. We form equations like this, and by using those equations we solve we solve the equations and find the values of those variables which are required. For example, in this case, suppose we are supposed to find the acceleration of the system, let us say. So what we will do, we will remove this variable tension. So if this is second equation, then and this is first equation, we have to think how can we solve these equations. We have discussed many methods of solving linear equations in class 10th, which are elimination method, substitution method, cross multiplication method. So we can use elimination method, because if we add 1 and 2, T will get cancelled out. So adding 1 and 2, we get, if you add these two beta, m at T minus M1G plus LHS of this M2G minus T equal to RHS of this M1A plus RHS of this M2A. Now the T gets cancelled out. Here we are left with M2 minus M1 into G, and here we are left with M2 plus M1 into A. So what is the formula for A? Formula for A is M2 minus M1 divided by M2 plus M1. समझ में आई बात? So using this value of A, you can also find the value of T. If you put this value of A in either of these equations, you will get the value of T. Okay, now let's take some more examples. Suppose this is a surface, and on this is a surface of a table, and on the surface of this table a body is kept, and another body is here, and a pulley is connected. And a rope is connected, which is passing over the pulley, coming here, and it is connected to this body, suppose. Okay, this is the system. Now it is given, apart from these forces there are other important forces also. One of the most important forces is friction, but we will take that friction as a separate thing, because that is very important and there are many concepts related to that. Now suppose the mass of this body is suppose 5 kg, right? 5 kg. Now let's not write kg. 5, and the mass of this body is 2 kg. Now what is being asked? It is asked that find acceleration of the system, and tension in the rope. Acceleration of the system and tension in rope. Acceleration of the system and tension in the rope. Okay, what we will do, we will make the free body diagrams of both the bodies. Now let's call this body as 1 and call this body as 2. Obviously when this system is released from rest, mass of this body is more and there is no friction, then this will go downward in this direction. Suppose it is moving with acceleration a, then obviously this body is moving towards right with an acceleration a. Now let's make the free body diagram FBD of 1. Let's make the free body diagram of 1. Now what are the different forces acting on it? Tension in this direction, it is going accelerating in this direction. Normal reaction will also be there because it is in contact with the table surface, and mg in the downward direction. Okay, since the vertical forces are balanced because there is no acceleration in this direction or this direction, then n equal to 2g. This is our first equation because the vertical forces are balanced, and the only force which is acting on this body in horizontal direction, that is T, and this body is getting accelerated in the horizontal direction. So T is responsible for that acceleration. So T is ma, m is 2, so ma, right? Now let's make FBD of 2. Now let's make FBD of 2. This body is not in contact with any surface, so there will be only two forces. We have taken tension in this rope as T. So this will also be T because this is the same rope, right? So this is T, and this is, what is its mass? It is 5. So this is 5g, and it is accelerating in downward direction. So obviously 5g is more than T, then 5g minus T equal to 5a. Now this is how you can make the equations, and now we have to find the acceleration of the system. Now let's remove T. What is the value of T? Value of T is 2a. Now let's put 2a here. 5g minus 2a equal to 5a. 7a is 5g. Let's take g as 10. So it is 50. So a is 50 by 7 meter per second square. So this is the acceleration of the system, and we also have to find the tension in the rope. So tension is 2a. So 2 into a, it is 50 by 7, 100 by 7 Newton. Tension is 100 by 7 Newton, right? Okay, we will discuss one more numerical when the body is kept on an inclined plane. Now this is an inclined plane, and suppose a body is kept over here on the surface of this inclined plane, and it is connected to a rope, and this rope is passing over a pulley, and it is connected to another body here, and a pulley is connected here. Okay, now this system is released from rest. This angle is given as, suppose, 60 degree. The mass of this body is again 5. Now let's take the mass of this body as 2. Now again this system is released from rest. Find the acceleration of the system and tension in the rope. Okay, what we do, beta? Why I have taken this question, especially inclined plane wala, just to explain you a concept. Then when we make the equations of the body which is kept on the inclined plane, it is very easy to make the equation if we take this as x-axis, that means the line which is parallel to the inclined plane, and this as y-axis, because the maximum forces that are appearing in this body, that are acting in this body, on this body, are either in this direction or in this direction, right? So we don't have to take the components. That will save much of our time. For example, what are the different forces which are acting on this body? First is the weight of this body 2g. Second is the normal reaction N. Third is the tension in this direction T. And what are the various forces which are acting on this body? Tension T, same rope, and weight 5g in the downward direction, right? Okay, so suppose this system is accelerating in this direction, because we don't know what will happen in this case, so we can take acceleration in any direction. If the direction is correct, then the acceleration is going to be positive. If you have taken the opposite direction of acceleration, then it is going to come in with negative sign, so that is not an issue. So according to this assumed direction of acceleration, the equation of this body is 5g minus t equal to 5a. Okay, so we have taken x-axis as this one and y as this. So what are the forces which are not in either x or y? Normal reaction is in y direction, tension is in x direction, but this weight 2g is not in x or it is not in y. So we have to take the components of this. If we have taken this as y and this as x, then we have to take the components of t and n both. That makes this solution a little bit complex. So to reduce that complexity, we take on inclined plane x-axis as this and y-axis as this. Now let's take the components of 2g. This component is what? Students, complete this line. If this is 60, then this obviously this angle is 30. And if this angle is 30, in this right angle triangle, if this angle is 30 and if this is 60, this is 19, then this is 30, right? And if this is 30, then this is going to be what? This is going to be 60. Got it? Take this, I'll rub it afterwards. Take this right angle triangle, right? This angle is what? This angle is 90 degree. Now if we take this right angle triangle, then this angle is 60 and this is 90, then obviously this angle will be 30, right? And now in this right angle triangle, if this is 30, then this angle is going to be 60. So this angle is very important for us to take the components. For example, okay, so this angle is 60. So if this is 2g, then this is 2g cos 60, right? This component is 2g cos 60 and this component is 2g sin 60. So you can directly make that the component which is inclined the plane is sin theta wala component, and the component of weight which is perpendicular to the plane is cos theta wala component, right? Okay, now let's make free body diagram of this body, and during the formation of free body diagram, we take x-axis as this and y as this. That's why we have made the concept of free body diagram in x-axis, because in this case our x-axis was this. So if we take x-axis as this, then in x-axis towards the left force is T and towards the right force is 2g sin 60, and in the upward direction force was N, and in the downward direction the force is 2g cos 60 and the acceleration in this direction, right? So the acceleration in this direction, so t is more than 2g sin 60 and there is no motion in vertical direction, there is no acceleration in vertical direction, so n and 2g cos theta are balanced. So the equation of this body becomes 2 minus 2g sin 60 equal to ma. m is 2, so 2a, right? And the values of these are given. So what's that? Hello. So values of all these are given, so we can find the value of t and a, है ना? Let's add these two equations, or let's just put the value of t, which is 5g minus 5a. Put the value of t here. 5g is 50 minus 5a minus 2g. G is 10. Sine 60 is root 3 by 2 equal to 2a. So by solving this, we can get the value of a. 5a plus 2a is 7a, and this is 50 minus 20 into root 3. Root 3 is 1.73 divided by 2. 10 into 1.73 is 17.3. 50 minus 17.3 is 32.7 divided by 7. So this is the value of a, which is 7 into 4 is 28, 47, 7 into 6. Approximately it is 4.6 meter per second square. And by putting this value here, you can find the value of t. So this is how you will do inclined plane wale questions. Apparent weight of a man in elevator. This is again a very important concept and derivation, in which we will find the weight of a man in an elevator. Suppose a man is standing in an elevator and the elevator is moving with constant velocity, right? And a weighing machine is kept in this elevator on which this man is standing, right? So man is applying, now let's make the free body diagram of man here. Man is applying a weight mg on the weighing machine, and weighing machine is applying a normal reaction, and since acceleration is 0, we can say that n equal to mg. But whenever you stand on weighing machine, the weighing machine is going to show the normal reaction, not your actual weight. If you press the weighing machine with your hand, the reading increases, because if you press the machine with your hand, the machine applies more normal reaction, so it just measures the normal reaction. So your weight is going to be same as your actual weight when the lift is either stationary or it is moving with a uniform velocity. Now suppose this elevator is accelerating upwards. Now what will happen? Your weight is mg downwards, elevator is accelerating upwards, normal reaction is upwards, and the elevator is accelerating upwards. So that means n is more than mg. So n, resultant force, is equal to mass into acceleration. So n is going to be mg plus ma. So that means this is the weight which the machine is showing, which is not your true weight. So it is called the apparent weight. So apparent weight is what? Your true weight is mg, but it is more than mg because it is mg plus ma. So apparent weight is more than the true weight. Apparent weight is more than the true weight. And when the elevator is accelerating downwards, when the elevator not the alligator, when it is accelerating downwards, now again make the free body diagram. Mg is downwards, n is upwards, and it is accelerating downwards. So mg minus n equal to ma. So which gives n equal to mg minus ma. Now we are subtracting something from mg. So we can say that in this case, the apparent weight, the weight which is shown by the weighing machine, is less than the true weight, right? And in case of free fall, suppose the rope of the elevator gets broken and elevator now falls freely. So in case of free fall, acceleration of the elevator becomes equal to g, which is acceleration due to gravity. So this a becomes g, and mg minus mg weighing machine will show 0, because in that case both the weighing machine and the man are falling with the same acceleration. So actually they are just, कहने को they are just in contact, but man is not applying any force on the weighing machine, so weighing machine will also not apply any force. And if this acceleration is more than g, then n is going to become as a negative, which means that obviously elevator is falling with g and man is falling with, elevator is falling with more acceleration, a man is obviously falling with g, so elevator will reach before the man. So man, with respect to elevator, the man will go in upward direction. Both are going in downward direction, but the acceleration of elevator is more, so it appears that man is going in upward direction. That means n is negative. Okay. Okay. So here we are going to solve a question based on this concept. Everything is given in this question. The weight of the man is 60 kg. And when he is standing on the weighing machine in an elevator, the elevator is going upward with constant velocity 2 meter per second. Okay, when the elevator is going first, this is not the A part, this is the first part. What is the apparent weight when it is going with a constant velocity? Then the apparent weight will be 0, because if the velocity is constant, there will be no change in weight. And when it is accelerating upward with 2 meter per second, then the apparent weight is mg plus ma. So in that case, weighing machine is going to show 600 plus 120, that is 720 Newton. And in third case, it is going downwards with an acceleration of 1 meter per second. The apparent weight that the machine is going to show is 60 into 10 minus 60 into 1. Now in case of downward direction, we are applying this equation. So W is 600 minus 60, that is 540 Newton. Right? Now let's take one more question. An elevator weighs 500 kg when the upward tension in the supporting cable. That's why I have included this question, because the equations that are being applied to the man are also applied to the tension part also. Suppose this is the upward cable and the tension in this cable is T. Now the elevator as a whole, with persons in it, with everything which is contained in the elevator, the total mass is m. So this rope has to support a weight mg. Now if the elevator is moving upward with acceleration a, then the equation becomes T minus mg equal to ma. So T is mg plus ma. It becomes more when the elevator is moving in upward direction. So there is a risk of breaking the rope, but this is not going to happen because these things are designed with utmost care. So tension nahi lene ka. Okay, so this is the equation, but what is given that when the elevator is moving in upward direction, the tension in the supporting cable is 50,000 Newton and the weight is 5,000 common aa gaya, so under is 10g plus a, right? So what is the acceleration? 50,000 tha na ye, 10 will be left, 10 by 10. So you can solve, and this is going to be 1 meter per second square. So acceleration of the elevator in this case, when the tension in supporting cable is 50,000 Newton, what is the upward acceleration pucha hai na? That is 1 meter per second square. And starting from rest, how far does it rise in 3 seconds? So we know the acceleration, we know the time, so we will apply the second equation. Starting from rest means u is 0, ut plus half a t square. So starting from rest, it is going to move in 3 seconds by a distance of 4.5 meter. Okay, the most easy part of this chapter is Newton's third law of motion, because everyone is familiar with this. To every action there is an equal and opposite reaction. For example, when a ball is dropped on the floor, why does the ball bounce back? Because the floor applies an equal and opposite force onto the ball. Ball applies some force on the floor, and the floor applies the same force on the ball. During our walking, when we push the ground at a certain angle in the backward direction, then the ground pushes us forward, and while swimming we push the water in the backward direction, and the water applies same force on us in the forward direction. In the case of launching a rocket, the gases which are coming out of the rocket, they apply some force on the earth, and in turn earth applies the same force on the rocket in the upward direction. So that helps the launch of the rocket, right? Okay, and that is the same thing when a boatman pushes the river bank with a bamboo pole. The water moves backwards, and the river applies the same force on the boatman in the forward direction according to the third law of motion. So this was the concepts of these were the concepts of Newton's laws of motion, and in next lecture we are going to discuss another very important concept, which is friction. So I will meet you in that lecture. All the best.